So in our last lecture, we studied about how collision takes place. So now we'll study about the elastic collision. Okay. So what we'll do in this study is consider two ball of different mass. So this ball has say mass m1 and is moving with a velocity v1 I means initial velocity. Agreed? And there is another ball which has a mass m2. Okay, and this ball is moving forward with the velocity v2 I. Now assume that v1 I velocity, that is velocity of ball 1, is greater than v2 I, that is velocity of ball 2. This will lead to a collision. So what happens in between? In between now they will collide. Okay, so once they collide, as I have talked earlier, they will first squeeze each other and then they will expand. So when they will expand, this ball 2 will exert. So I'm talking about the expansion part. Okay, just imagine they have squeezed. So so after collision, what happens? Say they squeezed each other. Okay, so here they have squeezed each other, and so this is the second step. They have squeezed each other, and then they will expand. So as I've mentioned earlier, when they expand, 2 exerts a force F on 1, and this reaction force by 2 on 1 decreases the velocity v1I. You have to agree with me on this part. And as a reaction, 1 exerts force on 2. As a reaction, 1 exerts force on 2, and this increases the velocity v2I. Agreed? So then after the expansion has been done, what is the next stage? The final stage after collision is they get separated, and now this ball 1 has a velocity v1f and this ball 2 has a velocity v2f. Agreed? So I hope you understood why the v1I got converted into v1f. It's because of the reaction force by 2 on 1 during expansion. And why v2I got converted into v2f? It's because of the reaction force by 1 on 2 that increases the velocity of 2. Agreed? So now, once this has been done, collision is complete. So this was the starting part of the collision where they were approaching each other, and this was the part where they collided, and this is what happened after collision. Agreed? And remember, we are always concerned with data that we have before collision. Okay, so data before collision, and then we are concerned with the data after collision. Agreed? Now what do we want to find here? Our main purpose is to find the values of v1f and v2f. That's what physics do. It's all about predicting. So what do we have at hand? We have the value of m1, we know the value of m1 and m2, and we know the value of v1I and v2I. So all the initial values are known to us, and we wanted to calculate the final values, that is v1f, v2f. Great. Okay, so since this is an elastic collision, the energy will be conserved. So what is the energy conservation law says that initial energy. So what is the initial energy? Initial energy will be comprised of half m1 v1 I square. So v1 I square means the velocity of the kinetic energy of the first ball. Similarly, you need to write the kinetic energy of the second ball. These are the kinetic energy of ball 1 and 2 before collision. Now since this is an elastic collision, the kinetic energy of ball 1 plus the kinetic energy of ball 2 after the collision has to be same, because we have considered this is an elastic collision. So this first equation directly represents the conservation of energy. Okay, now the second equation will be about the conservation of momentum. As I said earlier, momentum will be conserved whether or not this is an elastic or inelastic collision. So can you tell me what was the total momentum before collision? So momentum of the first ball was m1 v1i, and momentum of the second ball was m2 v2i, and when you add them you get the total momentum. Now you see, in the previous example there was a minus sign. Here we don't have minus sign because both the momentum are in the same direction. Okay, so this is the momentum before collision. What is the momentum after collision? Obviously it is m1 v1f plus m2 v2f. Now we have this two data and we need to find v1f and v2f. How do we do it? Agreed? Okay, so the approach is this. If you look at this carefully, then you find that m1 multiplied with, look at what I'll do, I'll make a difference in velocities. If I take the v1f on this side, then I'll get v1i minus v1f. So what is v1i minus v1f? It is the difference in velocity of the ball before and after collision. So v1 is the initial velocity of the ball and v2 is the final velocity. This is equal to what? um, let us find some space. This is not going to work. We need to find some space. Okay, and now take the v2i on the other side, and what do we get? We get an m2 into v2f minus v2i. Agreed? So this is just say simple algebraic manipulation. Now look at this carefully. Can you tell me whether v2f will be more or um, v2i will be more? Obviously, as I said, during the squeeze the velocity of 2 decreases. It means v2f must be less than v2i. Okay, as I've discussed earlier. Now look at this particular equation, that is equation number 1. Equation number 1 can be written in a fancy manner. If you take v1f to the other side, then what do we get? And you cancel the half everywhere, then you get m1, okay, bracket v1i square minus v1f square. Okay, and the other side, so we are deriving this from the first equation only. On the other side we have m2 multiplied with v2f square minus v2i square. Now so now what we need to do is we'll use the formula a square minus b square. You all know what is a square minus b square? A plus b into a minus b. So let me write it down. Okay, this is what we get. Now if you look at this for this one, the conservation of momentum says that m1 into v1 minus v1f and m2 into v2f minus v1i, they are same. So this gets cancelled, and whatever we are left with says that v2f, so v2f can be written as v1i, okay, minus v2i, agreed, plus v1f. Okay, this is the most important result that we get when we use the conservation of momentum and conservation of energy. So this important result will be now used in equation number 2. Okay, and then we can find the value of v1f and v2f. Agreed? Okay, so what's the target here? The target is to use the final expression, this final expression in this equation 2. Okay, and do some algebraic manipulation yourself, and let me just write the result. So the first result is, you can easily predict the value of the final velocity of the first ball if you have only the information of the initial velocities, and the relation is v1f is m1 minus m2 divided by m1 plus m2. We know that we already know m1 and m2, so we can easily calculate that, and this is v1I, so we already know the v values, initial velocity of the first ball. And the second expression is 2 m2, we know the value of m2, we know the value of m1. Okay, as I've stated earlier, all the initial values are known, into v2I. As I said earlier, we know all the initial values, so we also know the v2I. So we can easily predict the value of v1f if we know the initial velocities of the first and second ball and the masses of first and second ball. Amazing, right? Quite amazing. This is what physics is all about, predicting the future, what will happen next. Similarly, v2f has an expression that is m2 minus m1 divided by m1 plus m2, the same expression as above, into v2I. So it means if we know the initial velocity of v2I, and if we know, so this is 2m1 divided by m1 plus m2, and we need to know the value of v1I, that we already know. So we can easily predict both the final velocity. Amazing, right? We can easily predict both the final velocities only if we have the information of the initial velocities of the two ball and the information about their masses. So this is 1D collision, and physics helped us to predict what will happen after an elastic collision. So if you have two rubber balls and you collide them, then you can easily predict the future values of the velocities if the collision is 100% elastic. But in reality, most of the collision is inelastic. Agreed? So we have a coefficient called as the coefficient of restitution. And coefficient of restitution is defined as, see, if things are inelastic, then this particular thing will not work out. Okay, this particular equation came from equation number 1. Okay, and we know that equation number 1, if they don't satisfy, then it's an inelastic collision. So in an inelastic collision, you have this particular term called as the coefficient of restitution, which is defined as E as mod of v2f minus v1f. So we have v2f minus v1f divided by v2I minus v1I. v2I minus v1I. Agreed? So this is the coefficient of restitution. If E is 1, then we have a perfect elastic collision. Agreed? If E is 1, we have a perfect elastic collision. Why? Because if E is 1, then v2f minus v1. So you can easily see. Okay, just put E equals to 1 and you see it's an elastic collision. Now you put E equals to 0, and if E is 0, then it is a complete inelastic collision. If E is 0, we have an inelastic collision. And then most of the collisions, they do lie in our reality. We do not have either completely elastic or completely inelastic. So most of the collision lie between the value of 0 and 1. Agreed? So that's why most of the collision in real life, they lie between the value 0 and 1. So coefficient of restitution is between 0 and 1 in real life. So we'll discuss more on collisions in the next lecture.